Thank you, Lisa, for your kind introduction. Thanks, everybody. I think that we have disturbed your order a little bit, but we have decided to change the order just last minute, so sorry for that. But we are now sitting in the right order. So good afternoon, good evening, everybody, and thanks for being here also so late. It's already after 5, and the cocktail hour is waiting for everybody. So thanks for being here in the audience. And we're having today a panel with the subject Terminal and Modem Strategy, Innovation and Future Trends. So I have here experts with me from various sectors of the industry, and over the next little while we are going to try to find an answer to the question, why is it actually relevant having such a panel in the context of a MilSatcom conference, and which technologies will influence and form the market over the next month and years. Well, I took some inspiration from an article published on Space News earlier, dealing with NGSO broadband networks, and how they have shaped what customers expect from a user terminal. How it should be looking like, how much it should cost, that's a very important one, it has been mentioned already a couple of times today, and how easy it should be to set up. NGSO popularity also influences what customers expect to pay for their connectivity, and also sets expectations in terms of maximum throughput and latency. So looking at these facts, and according to our own experience as a satellite operator and service provider, most orders for SATCOM equipment in the military domain, however, they are in the single-digit domain, if we are lucky, in a 2-digit range. Well, and we have lead times of several weeks, if not months. So there's a big difference between the disruptive NGSO market and the more traditional business in which we actually are finding ourselves in. And if we want to grow together as an industry, so I think that these numbers do not really go together. So that's why we're here to discuss that. And with this in mind, Miguel, would you first of all share our experience? And second of all, how can we work together, as an industry across the board, and how can we react to the new customer expectations with creativity and, of course, also with innovations and future trends of your company, Insta?
Hello, good afternoon. Thank you, Joseph. So, Insta, right now, we are pretty focused in our current portfolio that is based in phase array antennas, passive phase array antennas, and we are providing solutions, user terminal, for several frequency bands. Also, we can provide user terminals able to manage several frequency bands in only one terminal, KU, KA, MIL-KA, or S and KA and MIL-KA. But I agree with you that right now, with the current portfolio, we are receiving a purchase order with only 1 digit or maximum 2 digit. So I think it's not good for us, of course, but also it's not good for the industry because the satellite providers also are having lower customers. I have to say also that we are pretty focused in mobility. I mean, man-portable terminals and also SATCOM on the move. Okay. So from 2 years ago, we are starting to work in electronical stable antennas. And right now, we are producing, we design and we are producing a terminal for OneWeb. It's called a FalseApt. In this case, this electronical stable antenna allows to us to design a terminal more compact, lower weight, is totally fully integrated, and also is easy to deploy. And the good thing is the price is much smaller. This is possible because this terminal is integrated a chipset from the massive market. And really, we are producing right now almost more than 1,000 units. So really, the thing is that the purchase order is 4-digit, so it's very, very good news for us. So how we can move this to the GOP SATCOM market? Right now, we are designing K-band antennas compatible with MIL-KA band, mainly for aeronautical platform, also for comms on the move and comms on the pause. So what we want to offer to the market is a terminal able to work with geostationary satellites, mainly in the spot beams, because these spot beams are more powerful, also oriented to the areas where they of interest. And really, the idea is also this design should be compatible with the new secure LEO constellation. So what we want to bring to the market, to the MIL-SATCOM market, is a fresh terminal, totally integrated, a small form factor, easy to deploy, and hopefully cheaper. Okay.
Excellent. Thank you so much for this insight. Well, so there's, the NGSO is not the first disruption in the market, I think. And now let's also look at this a little bit from an historical standpoint. So, Dave, according to your experience, so what has our industry, so the MIL-SATCOM industry, what have we already learned from past experiences? Can you please elaborate on that?
Thank you. Yes, and when you asked me this question before I came up, I've given it a little thought, I'll be honest.
Yes, please.
And I thought of two campaigns that span 30 years. So if I think back to the Gulf War, back in the 90s, it was a horrible war, but it was an interesting war because it was the first time that we saw industrial SATCOM equipment side by side with MIL-SATCOM. And the reason for that is we were not happy with reading about the war in our newspapers the day after. We wanted to see what was going on all the time. And I was working in industry and in the broadcast industry at the time. And once I moved into MIL-SATCOM, I was talking to some of my tactical command friends in the US, and they told me a great story. So they had deployed into Iraq with their big 3.8-meter trailer-based solutions with cabinets full of equipment. I think somebody on the earlier panel said 3 or 4 days to set this command center up, and was working perfectly happy in the desert. Now, back in that campaign, 90% of the communications was via satellite, and they used a mixture of MIL-SATCOM satellites and commercial. So one day, there was one of these embedded reporters come to their HQ to do an interview and interview the troops. And at that particular time, they were the tactical command were moving from a military satellite to a commercial satellite. So the guys are out changing feeds, changing everything else, and CNN rocked up with one of our flyaway antennas, one of our 1.5-meter antennas, set it all up, done their link, done an hour's shot, packed it all down, and drove off into the desert before the tactical command had even thought about changing bands. That blew their minds. And anyway, so that's the first campaign. So if we now move on 30 years to the latest one in Ukraine, the world has changed. We're not using big analog transmission, serial communication. The world has gone IP and cloud-based. So for information, for that tactical forward command sort of information, they turned to a high throughput Ka band satellite network, the Ka-sat, and was working fine up until 3 or 4 weeks in. There was a cyber attack allegedly by a hostile force, but it was a cyber attack that didn't affect any jamming. It actually went down and affected the commercial grade modems that they were using. Now, and that wasn't just in Ukraine. That took the whole of the network down. So the whole thing was taken down for 3 days. So there was no communication on that network for 3 days. Now, a patch was made, and it came back up again, but that is something, when we talk about sovereign secure communication, has got to be a slight issue. So then our friend Mr. Musk said, hey, no worries, if that's Ka-band system not working, you try my lovely LEO solution. Perfect, works lovely. And as we all know, we've heard many, many times in the conference during the day, yes, it does. But there was a caveat. You can't use it in occupied territories, Crimea. You can't use it right in the front line. So now we've got somebody dictating where or when we can't use the network. Now, I know the American DoD got involved and that got resolved, but that was something that we should really remember. So I don't know how much time I've got. So just coming back very quickly to what is Melexia doing to look at the future trends? Well, the first thing we've learned from MilSatcom, and MilSatcom has learned from industry, is that back in those deserts in Iraq, yes, we were using hardened commercial off-the-shelf equipment. This equipment had been flown in to Iraq, transported across the desert, assembled in the same harsh environment as the very expensive MilSatcom equipment, and worked perfectly okay for commercial bands. So MilSatcom thought, yeah, that's great. Us in industry thought, hey, we can change it to X-band and Ka band very, very simply. So the two went hand in hand. And my second, what we're also doing to secure communication is we're taking that hardened commercial off-the-shelf equipment, and we've actually, Melexia, been working on a roaming protocol which allows you to switch between satellites, either automatically or on the detection of interference or jamming. We also have multi-frequency quad bands, CXKU, military Ka bands, so you can change frequency in the field very, very simply. So that's one of our commercial off-the-shelf products. We're also working with our partners on a multi-orbit solution. So yes, I absolutely agree, LEO constellations and the hybrid network is a thing, it is going to come. There's no question about that. So we're working on those solutions and also integrating the 5G waveforms. So that's what we're doing to actually mitigate the issues.
Yeah, fantastic. Just a quick question, when you just have the mic. So do you think, you also mentioned Ukraine and the extensive use of LEO terminals in this war zone, but would you think that this is a hype curve that is currently now stabilizing or flattening, or does it continue? What do you think?
Yeah, I don't know if you're aware of the hype curve, but I've seen new technology from industry and from MilSatcom many, many times. And there's the slope of expectations, the plateau of realizations, and then the trough of despair. And that's where I think, and then you have this slow crawl up to implementation. Yes, the LEO networks were very good value. They were very commercial. And MilSatcom, the same as industry, embraced this with open arms. But then we've seen some of the limitations. Yes, there is a closed network. Yes, you are at the will of one person. It's not secure, sovereign communication. So I think we are getting there, and I absolutely think we will get there. And we just had to live through a little bit of pain.
Awesome. Thank you for sharing this with us. So we're just talking about the hype curve and that we see this stabilizing maybe at a certain point. But, Tom, what do you think about that? Because from what I read in the press, Kameda is not really stabilizing, right? So you're actually growing. So I know that you guys put a new factory up for the production of terminals. And what do you think about that? Because you're not stabilizing, you're growing. How do you do that? Can you please elaborate on that?
Sure. Good afternoon, good evening. I'll take a step back first, but Kameda today is what I call a substantially mature company. But just a few years ago, we were considered a disruptor. We came out with a flat panel antenna that basically eliminated a lot of the complexity around comms on the move. And unlike other flat panel antennas, we're not using phased array. We're doing it with a metamaterial-based technology that will eventually create holographic beams. I won't go into great detail about this because I'd have to hand out NDAs, but also I wouldn't be able to explain it that well. It's very complex. But it has certain consequences for comms on the move. The main is that it takes very little power, and it's really all across swap, but very little power is the key one. But also, it's just incredibly easy to use. You power it up and it works. So that's been a tremendous benefit for us. And such a benefit that through our partnership with OneWeb in 2023, we sold just under 10 times the number of terminals as we did in 2022. And when I mentioned this fact to Joseph, he asked, how did you ramp up production quick enough? This isn't working?
The sound, people are not so happy with the sound.
Should I take it off?
It's okay, they'll turn it off.
So Joseph asked how we were able to
ramp up production so quickly? And the answer is actually quite simple. We planned for this pretty exponential growth, and we did so by, in early 2022, we already started building a new factory. And that factory, we are building more than 10 times what we could build the year before, but it also has extra capacity, and we could probably triple it again. There are a lot of competitors behind us now with flat panel antennas, so we might not have such a huge market share with OneWeb, but we're doing pretty well. Even though we're very much connected with OneWeb, we've by no means forgotten our geo heritage. And you mentioned how one man managed to turn off a network. It turns out 10 days after that major incident, I ended up meeting the head of Ukrainian Special Forces. They were looking for an alternative solution. And in our geo antennas, today we have a GNSS denied capability. In fact, what our main thrust right now is a new product. It's called the Osprey HGL. It's our mill-grade version. HGL means hybrid geo and LEO. And I can announce that it's really out there. So it has begun in what OneWeb calls limited availability release. So it's basically beta testing. There's an expectation. Maybe we're being optimistic, but they'll have the general availability or the full release type approval by the SAT show, which is, I guess, 3 weeks away. And if it's not by then, it's going to be shortly after that. And at the moment, that product, it has essentially PACE in one box, because it has LEO with OneWeb, it has the iDirect 950MP for Transect networks, and Kymeta offers its own Transect networks for not quite global coverage, but we're getting there. It also has 4G LTE, and you can put in an external geo modem as well. So it too has, at least in geo today, the GNSS denied capability, but it does not yet have that for LEO, and that's coming shortly. I'd like to say within 3 months, but there's a lot of variables there. We think of this Osprey HGL as a tremendous achievement for the company. One reason we do so is that SOCOM, and we've worked quite closely across American Special Forces, but in their kind of future capabilities roadmap, they had a LEO geo in one box to come out in about 4 years from now. So to do it this soon, they're utterly shocked. Unfortunately, they were so shocked that they didn't have the program ready to start buying them, but we're now working on that. So we're happy with that achievement, but we still have a lot to do, and it's many of the things on INSTA's to-do list as well. So we're only in KU band right now. We want KA band as soon as possible, KUKA after that. We're constantly asked for the smaller terminal. Our U8 is called that because the antenna is 80 centimeters. At the SAT show, we can show off a prototype of a U5. We can also show off a prototype of a KA band antenna. The usual question is for the smaller antenna, but we're also asked for larger antennas, obviously for efficiency, but we're working on some new metamaterials that would allow much bigger antennas that would be conformal to the surface. So think top of an airplane, on top, wrapped around a vessel, things like that. So we have a lot of work to do, and we're constantly getting new requirements. We have to balance the investment required, the time to get these done. But we do this by working very closely with a number of European MODs and the Pentagon, and that's our next few years.
Okay, thank you. Just one additional question. It is, you mentioned that you want to expand into KA band. So if you add an extra gigahertz, the step to military KA band is not that far. So what does it actually take to bring this technology that you currently described into a military environment and also into the military band? So what does it require from your side?
So the KA band prototype that we have right now is at technology readiness level 5. And there's some parts of the company I'll never understand because I didn't do so well in physics, but it costs us about $40 million to take the current KU band and make it a KA band antenna. It's new materials, it's optimizing this special glass called varactors, things that I got to see live at our new factory. But so it takes a tremendous investment and a fair bit of time. And we were very close with Viasat to coming up with a deal where, and I don't know the details, but it was something below that $40 million mark of NRE, plus a commitment to buy X thousands of terminals. And the Viasat 3 satellite, I believe it made it to orbit, but is not working as expected. So that kind of got in the way. And now what we're doing is talking to multiple Ka-band satellite operators, and maybe they can form a syndicate or similar. And the idea is that not every Ka-band satellite's identical, but if you come join this, we'll make sure that our antenna will work on your satellite. So the WGS and GovSat, of course, could very much be part of that.
Cool. No, thank you very much. So what we just learned from Thomas, actually, that there is willingness to invest R&D, so research and development money into military frequencies to actually seed the market. And what we should aim for is actually to use the economy of scale, right? So that we have just learned in terms of numbers to actually bring the terminal prices down. Well, now, Mark, next to the hardware aspect, what can actually standardization and virtualization bring to be more cost-effective for the end user?
So I'd like to start off with a little bit of history and a talk about virtualization. When I joined Satcom in 2000, we talked about a software-defined modem. And that's great, right? It works in an FPGA, a specific piece of hardware, and it's customized to that. So now a little history. In 2015, the first disaggregated modem came to the market. And when I talk disaggregated modem, and when I talk a software-defined modem, I'm talking about a piece of software that runs on a CPU. No FPGA, no GPU, nothing custom. Take any server you want, load this piece of software on it, and you've got a modem. So Kratos has been marketing software-defined modems for the TT&C market and for the Earth observation market since 2015. There are over 100 companies today that use this technology every day. There's one company that takes over 50,000 passes a month from a LEO constellation using software-only modems. One of the things that enabled this to work was Diffie. So we've heard about that earlier. Some of you may not be aware of the Diffie standard or how it came about. So in about 2016, Kratos and Comtech got together and tried to make an early version of this disaggregated modem work. And we found that the Comtech stuff didn't really talk to the Kratos stuff, and the Kratos stuff didn't really talk to the Comtech stuff. Why? Because it was a precursor to Diffie. It was called Vita 49. And it had so many different implementation things that you could do that we implemented it differently. It didn't interoperate. Years go by, Kratos says, hey, this is a problem. The US government says it's a problem. Intelsat, Microsoft got together and said, you know what, we need an interoperable standard. And that's how Diffie came about. Went to the IEEE, got it defined as a IEEE standard, put together a standards body, and now there's over 53 companies that are part of the Diffie consortium. Last year, late in November, there was the first Plug Fest. 8 different companies got together, brought their Diffie devices, and these were Bucks, LNBs, these were digitizers, and these were software modems that other vendors other than Kratos had brought to the table. And they did an interoperability. And the results are confidential and only shared among those 8 companies so that we can encourage for the next Plug Fest that other companies will come knowing that if they don't perform as well as they'd like or if they fail a test, that nobody will know other than the people who were involved in the testing, and they're all under confidentiality, not to expose it. So if you hear PlugFest and you want to get involved with Diffie, go to diffieconsortium.org, sign up and join. It's open not only to vendors, but also to end customers. As a matter of fact, many of the Diffie board members are end customers as opposed to vendors. So that was one place that was standardized. I talked about TT&C modems and Earth observation modems. Those are kind of a gateway infrastructure. So the next thing that needed to happen is to move this into SATCOM. We already had a modem that was doing 800, 900 megabits per second on receive. All we had to do was create the transmit. But the problem was that you need something to orchestrate and to manage the modems at the gateway. So we created the open space platform. And one of the things we did is we called it open space. Open means it's open to everybody to participate in. And so there's several different ways that is come to fruition. It also means it's based on open standards. So if you go to type in Kratos Open Space on Google, it'll take you to what is Kratos Open Space. Go to that page, and you'll see all the different standards that we used for the orchestration layer and for the APIs. So some of those standards are Metro Ethernet Forum E-lines. If you go out and talk to Rivada, they'll tell you how great E-line is for military applications. That's in the product, and it makes it very easy for any program to send the orchestrator a command and saying, I need this service, here's what my service name is, and please bring this service up for me. So we heard earlier this morning about 17 days. How about 17 seconds? All right, take my API call, I go to my portal, I say, I need 1 megabit to the Ukraine right now, and I put that in the portal. If everything's been predefined as it should be, and you're authorized to do it, shouldn't take more than about 17 seconds to come up, and you've got that link established. You want to change it? You need that to be 50 megabits now? Again, very quickly done. And it's because we're using standards not only to bring in the request, but between the layers. So now, okay, let's talk about between the layers, the APIs. We decided to go with 2 different standards on that. One is MEF, and the other one is the TM Forum. The TM Forum is a telco organization that got together and solved the management, the BSS OSS problem for the telcos. There's a bunch of vendors you can buy the products from, but they all implement these standards. Last year, we decided to do a demonstration that was sponsored by Airbus, SES, and OneWeb. And what they wanted to be able to do was to have somebody log into a portal and do multi-orbit changes through a portal connection using TM Forum off-the-shelf vendors who support TM Forum software, off-the-shelf vendors, off-the-shelf software. It took us 3 weeks to bring those APIs into our system and allow that orchestration to happen. So those are some of the benefits and some of the standards that can help. And I've been talking a little bit about the gateway, but this is a terminal discussion. So let's go on the terminal. If you take your terminal and get one vendor's piece of hardware, you're locked into that vendor. So what did I say about the software modems? They run on a PC. They run on a common compute platform. It's true at the terminal as well. We're also working with several terminal providers that are been making terminals for many years to build terminals for us based on the DVB RCS2 standard. So now if you've got a terminal, maybe it's running a standard compute, and you want to add functionality to it. You don't like the transect that Kratos produced. You like somebody else's transect. As long as it's in software, you load it on there, and your terminal is now running that transect or that other protected waveform that you want. So now the terminal becomes multi-orbit, multi-waveform, and can be multi-vendor if the vendors get together and start to create these custom, create software-defined radios, true. Another way that the modems can integrate in is at the gateway. I talked about these TM Forum standards and the MEF standards. Those go between the layers. So you can take your own waveform. Say you're a military, you got this old waveform, you really love it. It can be onboarded into the open space platform, and now your custom waveform is running there. We don't see the data. All we do is we tell it what to do and when not, and we tell it when to spin up and what to do and where to send the information. Now you can use your old remote sitting out there that's out in the field that you would hate to replace. That's a way to migrate into this new paradigm. Because it runs in software, I'm going to finish up here pretty quick. Because it runs in software, you can run it in the cloud, private cloud. Today, we run it in Azure. We did a demonstration a few months ago where the gateway was in Peru and the hub was in Virginia. The other thing, because it's in software, it's very, very quick and easy. 3 weeks. 3 weeks it took us to get working with an existing SCPC modem on the market. So this was a vendor who said, yep, we would love to have a hub. We don't have a hub. Go for it. Here's our modem. We plugged it in, and within 3 weeks, we had everything working. We had to make some customizations to our IP packet processing, but other than that, it worked. So one of the advantages of having a remote that is standard for all platforms and all waveforms is it's going to be mass-produced. It's going to drive the cost down.
Well, thank you, Mark. This was very impressive. And when you talk about virtualization of the hub and also of the remote through using technologies like RF over IP and also software-defined radios, well, and all the points that you brought up, Nicole, is this the end, basically? Is this the end of the good old 19-inch rack modems that we have all in our teleports and that we love so much? Or what is actually being developed and designed on Comtech's drawing boards right now?
Yeah, on the contrary, it's only just the beginning, in fact.
Good.
So I think what we've heard a lot about over the course of today, I know it's been a long day here, we've talked about multi-orbit, multi-frequency, multimodality. We've talked about a myriad of different technologies. We've focused on the satellite itself. And one of the biggest things I think we're finding in the subject of innovation and trends, we need to reorient the direction of the conversation away from the satellite, away from the technology, and toward the end user. So what is it that they're trying to do? If it's about a geospatial end user, they want to shift away from raw pixels, slinging raw data, to instead having analytics, to having insights, information that helps to make a decision. If it's about satellite communications, we've shifted away from the focus and obsession over which orbit, which frequency, which transponder, what's my lease agreement. Instead, where do you need connectivity? What are the applications driving demand? And allow that to inform what's the best solution. And in all of that is a brain, and in that brain is the modem. So I think this is the era of the modem. When we think about the multi-orbit, multi-frequency, multimodality, all of the wonderful things that our networks need to be able to do, it starts with a cognitive network. It starts with that modem. So really at Comtech, that's what we've been up to over the span of the past year in particular, is how do we take what is, the equivalent of a laptop-sized modem capability and empower it to an end user so that they can operate if they're on the move, if they're at sea, if they're on the pause. They're able to take advantage of the variety of networks that we've talked about over the course of the day today. They have access to that always-on critical capability where and when they need it most. Similarly, for our geospatial customers, how can they be assured to receive that geospatial insight so that they can make a decision when it's most critical? The new CEO of SES, Adele, just earlier today, talked about being software defined. That's from the satellite to the modem to the terminal. All elements of that really is part of the secret sauce of what we're working on at Comtech. When I talk about there being a laptop-size modem technology that enables all of those different modalities and frequencies, thinking even smaller than that. The size of a credit card that goes on board major airlines. It goes on, aeronautical vehicles to be able to deliver connectivity that's always on regardless of the orbit. So it's really an exciting time for modem. Yes, I think if you follow the trends of hardware sales over the last 5 years, you'd see a fairly steady decline of equipment sales. This isn't that. This is the brain inside of a cognitive network. So really excited to dive into that a little bit further with you today.
Perfect. Thank you so much. And you brought it out actually that there is a decline in numbers actually in terms of equipment, but we have just learned that there's trends actually going against that. And we as industry should really focus on that and try to change this trend. But one important thing that I also wanted to mention here is the customer perspective, okay? Because when we design a service, when we design a product, we have to listen to our customers as well. Actually, they have a lot to say when they are writing statements of work, for example, when they put requests for proposals out. So one question that I would like to ask you, Dave, actually, what would you recommend policymakers and writers of statement of work, and how can they influence and how do they influence actually also the terminal cost, and how is this all related together?
I wouldn't be hello.
Works,
I wouldn't be so arrogant to tell a spec writer how to write their specs. That'd be crazy. But the one thing I would like to ask them is what you said there, Josef, is that communication. So I'm nowhere near as highfalutin as my fellow panelists here, but I see many an RFP come onto my desk for tactical terminals or hardened COTS type equipment. And I look at these specs, and if I can talk to the end user, I've talked to GovSat, I've talked to various people, and I know what they want to use these terminals for. And then I look at the spec, and I say, I think you have just put zero after zero on the price of this terminal for no apparent reason. I'll give you an example, fungal mold growth and nuclear hardened terminals for things that are going to be used for welfare. That to me sounds crazy. So really, what I'd like to say is more communication. That I think would be understanding. And I quite often say, and many people have heard me say this before, there's an antenna for every application and every budget. And if you can actually talk to people and actually find out what the application is, you can find out the perfect terminal at the right cost.
Thank you. I think this is really a valid recommendation. Just fairly quickly, Miguel, one question for you. Because earlier in the press, I have read that the U.S. Army actually intends to launch a new procurement of satellite communication terminals through the so-called Family of Terminals-Large program. So I think that there is already the first attempt to modernize and also to consolidate requirements. So what do you think? Is this the right approach, that you actually group terminals for a purpose in terms of commonality and logistics?
Yeah, I think that it's important for the people in charge of write the requirements of the network to take into account the user terminal specifications, because if we want to maintain a small form factor terminal capable of working in several networks, it's important that the network specification should be writing thinking in this possibility. For example, when Nicole said that Context is thinking in designing a modem able to work in several networks, satellite networks, I think it's very important also for us, because we have to integrate a modem right now for a different network. So if we want to simplify the size, power consumption of the modem, it's important that the modem should be interoperable with several networks in different situations. So I think it's important that the people in charge of writing the requirements also thinking in simplifying the user terminal. So it's something that I would like to request, because it's not as difficult to offer something small and with a lower price. Okay.
Okay, thank you. Well, Nicole, last statement, also a bit cautious of time. So in your view, how can industry, and represented also by this panel, how can industry work together and partner for the benefit of governments?
Somebody said it earlier. I think it might have been the panel just before ours. They talked about open architectures and the fact that had not been really a double click over the course of the day today. But I think there's something to that. When we think about the importance of this event and related events for having industry and government collaborate and cooperate early and often about requirements so that we in industry are progressing and developing new capabilities that are right-sized to meet the need of the end user. That's very important. But sometimes we forget that we need to collaborate as an industry as well. We had the prep call for this panel just a couple of weeks ago, and a number of the colleagues here said, oh, actually, we're using Comtech today, and here's how we're using it. And there was a lot of that cross-pollination that's happening. I think all too often we view one another as competitors instead of competimates or partners, but we all occupy an important responsibility and role in this industry to collaborate, to allow our architectures to operate in such a way to bring the best technology forward for our US, for our allies, for those with whom we have mutual defense agreements, so that they have the very best available from commercial today. So I think it's just as important having industry and government collaborate, policymakers collaborate, those who are planning for the budgets, but critical that this group of industry participants do the same.
Cool, thank you very much. So, as we also want to leave maybe some room for a question or two from the audience, let me just very quickly summarize what we have brought up here from you as our experts. So, I think that we can summarize that if the Mail-Satcom sector wants to grow and actually needs to grow for the benefit of the governments and also our customers, we need to have strong partnerships in place. So I think this is one key takeaway from here. We need to standardize on the modem and also on the terminal side so that we can actually standardize production and use economy of scale to bring the terminal prices down. So I think this is really, really important. We also talked about digitalization and virtualization, and this is one of the major trends that will play a key role, as Nicole and also Mark pointed out. We also touched on multi-purpose and multi-band, so a trend that allows to use the terminal in various areas and for multiple purposes. This also is one of the efficiency generators. And last but not least, I also think that there is some hidden potential that we can unlock together with industry, also with governments or even operators that invest into R&D money, because there is hidden potential. And from my point of view, and this is what we pointed out here on the panel, it requires courage and also entrepreneurship to unlock this potential. And yeah, we are really looking forward to seeing this over the next month and years. So thank you to my wonderful experts here on the panel. It was really, really great having you here. And now I just quickly look at Lisa, our moderator. We just finished on time, so maybe we have still some moment for a short question. Thank you.
Thank you for asking me. I know that you've had your hand up for a while, so I think you're desperate to ask a question. So. Yeah, a microphone will come to you. Or you can jump up. There's a microphone.
Just two questions, observations. When you talk about gateway and hubs, I mean, these terminologies are floating around in the industry at the moment. So talking about gateway and hubs, could you just, for my benefit, just explain what do you mean by a gateway and what do you mean by a hub?
All right. A gateway is typically, in my viewpoint, a gateway includes the antenna and all of the infrastructure, including the baseband systems. When I use the word hub, it's probably my old VSAT training. I think of that as the baseband system, the system that brings in our case, a diffie signal or a RF signal, and then turns it back into a usable data and works to share the bandwidth among different users and different satellites.
Thank you. And then just one observation, Nicole, on the cooperation side of things. I mean, I had the benefit of being part of the ARINC 781 group, which defined the cockpit light SATCOM for the cockpit of aircrafts. And it was a kind of, for me being a competitive person, it was quite odd to sit among Honeywell, Rockwell Collins, Cobham, and other players in the same competing airlines. Airbus and Boeing were also in the room. But ultimately, the early standardization work within that work group has now become a standard and equipment sitting on aircraft, both at Airbus and at Boeing today in large numbers. So it was against my instinct, but it was very good fun, and now it actually is a reality. So it can be done.
Any other questions? Oh, we have somebody waving over here. Yeah, somebody waving over here. That will be the final questions just because of time. Although I do like the question part because it's when everybody wakes up and I get the lights on you and I can see who's alert.
Yeah, hi. So I'm Dave Brunemeyer with Space Systems Command. I'm an SCNI, and we're doing standards for Agile terminals through MOSA, ISTO, IEEE in the States. I'm wondering what's going on in Europe with regard to similar standards to allow terminals. I have a terminal, I want to be able to use it with multiple systems. So there's certain data standards and interoperability standards that are necessary. What's going on in Europe in that domain? Thank you.
So I think, I don't know, one of you guys taking it? You are? That's a tricky question. We need to decide who's going to answer. I know when it comes to standards, Nicole or Mark, is this something where you want it? Okay. All right. So you asked the right question, right? So I think we need to wait to the cocktail event. We need to brainstorm a bit, and then we come back to you.
Do you have an answer yourself?
Yeah, in the back of my brain someplace, I do actually think that there's some NATO activity going on in that area, but I'm not that close to it. Again, what we're doing is with MOSA, ISTO, and it's IEEE, but it's Agile Terminal Interface, ATI. And that's basically started off as a Google protobuf standard for data schema. In other words, what commissioning data does a terminal need, a modem needs specifically, to operate with Viasat, Inmarsat, et cetera, right? And so that's the starting point. And the next one is Service Provider Interface, which allows enterprise management and control to actually manage that terminal and the hub, not the gateway, but the hub as well. So that's where we're starting off, and there's a number of other standards that will follow. And so we do definitely want to coordinate with NATO or ANSI or whoever else would be interested in doing standardization in this area. Thank you.
Thank you for the question. Are there any other burning questions? No. Okay. Joseph and panel, thank you so much. Thank you.